two new theorems. The first is Rolle's theorem. It's written up here for you to take a look at. If f is a function that satisfies the following three conditions: 1, f is continuous on the closed interval a to b. 2, f is differentiable on the open interval a to b. Notice that it says differentiable. That just means that the derivative is continuous. And then part 3, f of a equals f of b. Then there is a number c in the interval a to b. Notice that it cannot be equal to the endpoints such that f prime of c is equal to 0. Okay, so let's take a look at how to use this problem. Basically, what they're saying is if there's 2 points where you have equal values and it's continuous, it's differentiable, it could look something like this. Notice that, let's say this is A, this is where B is. We're going to have equal values, f of A equals f of B. Okay, somewhere in between, derivative is equal to 0. This would be where that would be, because we would have a horizontal tangent there. Okay, and it could be the reverse. You could have this flipped. It could look a little different, but basically that's what it's saying. If there's 2 places where you have equal values and the function's continuous and differentiable in between the 2, then there's somewhere where the derivative is equal to 0. So basically there's a horizontal tangent somewhere in there. All right, first example. Find the value of c that satisfies Rolle's theorem for the function f of x equals x to the 4th minus 2x squared on the interval -2 to 2. So the first thing that we have to check are all the conditions. So first of all, is the function continuous? Okay, well, it's a polynomial. Those are always continuous, so we're good there. Okay, is it differentiable? Which means, is the derivative continuous? So let's think about what would the derivative be. It's going to be another polynomial, 4x cubed minus 4x. Yes, that's continuous on the interval. And then finally, is f of a equal to f of b? So is f of -2 equal to f of 2? Notice that both of our exponents are even, so those are going to become positive, and we're plugging in a -2 and a +2. So when we plug those in, we will get equal values. They both equal 8. Okay, so that works. So if all 3 are true, then we know somewhere in between these 2 values, the derivative is equal to 0. So let's set that up and solve. We said derivative is 4x cubed minus 4x. Let's set that equal to 0. We could take out a 4x. That would leave x squared minus 1. So we're going to get 0 and positive or -1. Now, the last thing that we need to do is check that these are contained within the interval. Remember, it cannot be equal to the endpoints. So 0 and positive and -1 are contained in between -2 and 2. So 0 and positive or -1 are all the values that would satisfy Rolle's theorem for this function on this interval. Okay, let's try another couple. Number 2 here, we've got the function 1 over x squared on the interval -2 to 2. Okay, so we want to start by checking our conditions. Is this function continuous on the given interval? Well, we know that the only place this one's not going to be continuous is at 0, because that would make the bottom equal to 0. We have an asymptote there. So is 0 on our interval? Yes, it's in between -2 and 2. So the way we would write one like this, Rolle's theorem cannot be applied because f of x is not continuous on the given interval. Now, let's say they had told us a different interval. What if they had said from 1 to 4? Okay, then our problem would have been different. It would have been continuous on the given interval, and it would have been differentiable on the given interval, but f of a would not have equaled f of b at that point, and our reason for why Rolle's theorem couldn't be applied would have changed. Let's take a look at the next example down here. Find the value of c that satisfies Rolle's theorem for the function 2x squared minus 3x on the interval 1 to 6. Okay, so first thing we need to check, yeah, right here. Okay, why is my pen acting up? Let's see. First thing we need to check is the function. There we go. Continuous. Again, it's a polynomial. They're continuous everywhere. Okay. Next, is it differentiable? So is the derivative continuous? Derivative would be 4x minus 3. Okay, that's just another, it's a linear function. That's always continuous. Okay, so the last thing that we need to check is f of 1 equal to f of 6. This one isn't as easy to see as our first example. So let's take a look. If we plug in 1, we have 2 minus 3, which is negative 1. Okay, let's check it against 6. 2 times 6 squared minus 3 times 6. So 2 times 36 would be 72. Minus 36 would give us 54, which is not equal to negative 1. So for this one, excuse me, Rolle's theorem cannot be applied, if I could write, because f of 1 is not equal to f of 6. Okay? So you could have multiple reasons why Rolle's theorems might not work, but you do want to go in order. Check each thing in order. Next, we're going to take a look at mean value theorem, which starts out very similar. Your function has to still be continuous and differentiable, same as you started out with Rolle's theorem, but there's a new piece. Instead of worrying about whether f of a equals f of b, mean value theorem goes straight to there's some number c in that same interval where f prime of c equals f of b minus f of a over b minus a. All right, let's take a look at what that might mean and what that looks like. Okay, so this is mean value means average value. So we're saying somewhere the slope is equal to the average value, which makes sense. Slope is looking at the rate of change. So if we're talking about a rate of the average, okay, average value, somewhere the slope is going to be equal to that average. So let's take a look. We have the function 5 minus 4 over x on the interval 1 to 4. So first thing we need to check still, is it continuous? And this one, the only place this function is not continuous is at 0, and 0 is not on our interval. So we are continuous on this interval. The next thing we need to check is, are we differentiable? Okay, so let's think about taking derivative. This one we could rewrite as 5 minus 4x to the negative 1. We take the derivative. That's going to give us, derivative of 5 just goes away. Negative 4 times negative 1 is positive 4. X to the negative 2, which is 4 over x squared. Okay, this one is not continuous. The derivative is not continuous at 0, but again, 0 is not on our interval, so we're only worried about 1 to 4, so we're good there too. Now, let's take a look at what mean value theorem said. Somewhere, the derivative is going to be equal to f of b, which is 4, minus f of a, which is 1, over b minus a, so 4 minus 1. So we already found the derivative. We said that's 4 over x squared is going to be equal to, okay, let's plug in 4. And I'll just write it out to the side. Okay, 5 minus 4 over 4, that's 5 minus 1, which is 4. So 4 minus, okay, let's take a look at f of 1. 5 minus 4 over 1, 5 minus 4 is 1. So 4 minus 1 over 4 minus 1 is just 1. If we multiply by x squared, 4 equals x squared, so x is positive or negative 2. Now, last thing we need to do is check, are our solutions on the interval? Are positive and negative 2 both on the interval 1 to 4? No, only positive 2 is. So the C value that works, in this case, the only one is positive 2. Okay, again, it has to be contained within our interval. Let's try one more. Find the value of C that satisfies the mean value theorem for this function on the interval. Okay, first thing we need to check, are we continuous? This function is not continuous at x equals 0. Is that on our interval? Yes, it is. So unfortunately, when we have this problem, we would simply say mean value theorem, which, by the way, you can abbreviate as MVT. That one is an accepted abbreviation. Cannot be applied because f of x is not continuous on the given interval. Okay, guys, if this is a free response type problem and you don't write out this answer with your reason, you're not going to get full credit. You have to make sure that you list a reason, and you do want to go in order. This function is potentially also not differentiable, but that doesn't matter because you go in order. What's the first thing that doesn't work? In this case, it's not continuous, so we don't check anything further. That's the first thing we check. If it doesn't work out, that's the reason why we cannot apply the theorem. Okay, hopefully these should be pretty easy, guys. Both of these theorems are pretty easy to work with. You just have to memorize the conditions that have to be met and then the formulas to use.